Love that when settings change. There we go. So we finally get audio for here. Love that. So we're gonna have our 3 secant squared theta equals, adding 4 to both sides, we're gonna equal 4. What are we gonna do next? Divide by 3. So we're gonna get our secant squared theta is our 4/3. Now what can we do? Yeah. I don't want to know what secant is. I don't know what secant squared is. I want to know what secant is. So if I square root both sides, that's going to give us secant of theta equals what? But what do we need to have when we square root both sides? Plus or minus 2 square root of 3. 2 over square root of 3. Secant is related to which trig function? 1 over cosine. So 1 over cosine is the same thing as our plus or minus 2 over square root of 3. So our cosine, yeah, that's something significantly more familiar, is our plus or minus square root of 3 over 2, which is a unit circle value. Those are things we know. So remember, on our unit circle, when we're looking at our ordered pairs, it's cosine, then sine. They're in alphabetical order. So we're looking at the x values here.
We're looking at all the positive and all the negative.
The whole unit circle. And we need all things that are going to have a positive square root of 3 over 2 or a negative square root of 3 over 2. So what are our options for our theta? Pi over 6. 5 pi over 6. 7 pi over 6. And 11 pi over 6. And that is it. No plus pi ends, no nothing. Just those 4. It is a finite list because we are only looking at this interval. All of our answers need to be between 0 and 2 pi. Because we're only on the interval, because it says in our instruction to find our solutions on the interval. So we only care about the unit circle. We don't care about coterminals on the interval. So it's the same solving process, it's just that we stop our answers a little bit earlier. Okay. Questions on this? Okay. I'm gonna give you a funky one. All right, so here's our next one. We've got secant squared of theta plus tangent theta equals 1. And we go, ew, 2 different trig functions. Gross. I'd really rather we didn't have 2 different trig functions. Do we know a trig identity that'll relate our secant squared somehow to tangents? One of our trig identities is that tangent squared plus 1 equals secant squared. So in order to not have 2 different trig functions, we can use this. We can substitute this piece in place of secant squared because they are equivalent. So I can rewrite this secant squared as our tangent squared theta plus 1 we've got our plus tangent of theta equals 1. That is a wonky equal sign, but that's okay. What should we do next? Subtract 1. I'm going to minus 1 from both sides. That's going to give us tangent squared theta plus tangent theta equals 0. What can I do now? How's that helpful? Factor. What can we factor? There's a tangent. They both have tangents. So I can write this as tangent theta times tangent theta plus 1. The reason this is helpful is because now that it's a product, we can do just like we used to do for quadratics, where I take each factor and set it equal to 0 to figure out where my answers are, where my root solution zeros were. So we're going to set this guy equal to 0, and we're going to set this guy equal to 0. So we're going to figure out where tangent of theta equals 0, and we're going to find out where our, getting slightly different color, not the one I wanted, that one, tangent theta plus 1 equals 0. So when we have a product, we can split it apart like this. We can't do that up here because they're a sum. So we need them to be a product. We need them to be multiplied in order to be able to do this. Okay. So where do we have our tangent equals 0 on our unit circle? If it's not something we spot, remember, think about tangent being sine over cosine. And if I need it to be 0, that's the same thing as having 0 over 1. So where do we have sine of 0? I was going to say, we're going to have sine of 0 at a couple of places, right? We have it at pi and 0. Think about our interval. We go from 0 to 2 pi. 2 pi is not included, so we're not going to include 2 pi. But we include 0.
You can't include 2 pi, but you can include 0.
Correct, because of the bracket on the 0 and the parentheses on the 2 pi. It is 99.999% that. So for our tangent plus 1, it's a very similar vibe, except we're going to subtract 1 from both sides. So we're going to have our tangent theta is -1. Where are we going to have tangent be -1? For it to simplify down to be -1, they have to be exactly the same, right? Top and bottom? So think about our square root of 2 over 2's. Those guys are always matchy-matchy. It's just our signs that are different. So which quadrants are going to give me negative tangents? Our quadrants 2 and our quadrants 4 will give us negative. So I need to have one piece that's negative because 1 and 3 are going to be positive. So our tangent here, we're looking in quadrant 2 first. The one that's going to have my negative square root of 2 over 2 and our positive square root of 2 over 2, that's our 3 pi over 4. And then if we look in quadrant 4, where we're going to have another one that's going to give me a -1, we're going to be on our 7 pi over 4. Our over 4s are going to be our tangents are 1. 1 or -1. So quadrants 1 and 3, it would be +1. Quadrants 2 and 4, it would be where we have negatives. So these are, excuse me, all of our answers for theta. Like this. And that one's kind of wonky and it feels weird. Some of these are awkward and weird and feel really, really foreign. Okay, let's do another one. Let's just do one more. Okay, we have a little bit of time if you guys have any questions on stuff. Okay. Let's look at this one. We've got 2 cosine of x, sine of x. And we want to know when that equals sine of x. And we are still on our unit circle interval. So we're still just looking at the unit circle. What in the world should we do first? I understand the instinct to divide by sine of x. If it was sine of 2, 100% go for it. But since there's an x in it, if we divide by sine of x, we run the risk of losing out a solution because it would cancel out an x term and we would lose a solution. So I understand the impulse, but we're going to fight that one. So we're not going to divide by sine of x.
I said 2.
Dividing by 2 is a thought. It's not going to make things easier at this point. When in doubt, get all of our trig functions on the same side of the equal sign. Subtract sign is the way I would recommend. I was like, you could go the other directions, but honestly, they're going to make it harder. I'm going to subtract sine of x from both sides.
And we can't cancel those out, right?
They do not cancel out, correct. Because it is being subtracted from this product, these two things are being multiplied. So what we have here is we have 2 cosine x sine of x minus sine of x equals 0. Since we don't have anything squared, we're not going to have an identity. The Pythagorean identities always have a squared piece in here. Good thought, though. Good thought. What else do we notice now about this purple line? Do we have anything we could factor?
Oh, sine.
They both have signs in them. So let's factor out a sine of x. Since both pieces have signs, let's take that out. It's going to give me a leftover bit of 2 cosine of x minus 1. And now that we have a product, we can split it. Because we want to know when our sine of x equals 0 on our unit circle. And we want to know when 2 cosine of x minus 1 equals 0 on the unit circle. So whenever we get a product is when we can split things apart. But it has to be multiplied in order to do that. It's based on one of those fundamental theorems of algebra kind of deals. So when we have sine of x equals 0, what angles is that? What angles of x give us a sine of 0? 0 and pi. Right hand one, we're going to have a little bit more to do. What do I need to do on this guy, my 2 cosine of x minus 1? Add 1. So we're going to have our 2 cosine of x equals 1. Dividing by the 2, because you're just a half step ahead of me there. Yep. We're going to have our 1/2. So we want to figure out what values of x, what angles are going to give us a cosine of 1/2. Pi over 3 and 5 pi over 3. And those are all the values in the unit circle that are going to make this statement true. Like, and if you ever want to double check it, you can always go through and do cosine of 0, sine of 0, sine of 0, and see if that's going to equal each other. 2 times cosine pi, sine of pi should equal sine of pi. 2 times cosine of pi over 3 Sine of pi over 3 should equal sine of pi over 3. Like, they will work. It will check. We don't need to because that's doing a whole lot of. Okay. Questions on this one? We have 10 minutes. Do you guys have any questions on things like in 7-1? Because we have a quiz for 7-1 tomorrow. So if you have any questions, now's a really great time. I do have the answer key up for 7-1 on the Canvas page. I just posted it before third period, so that I could say it was up. So it's up, but we have a quiz over it tomorrow. There's not a separate answer key or separate review since it's over a single section. The review is the homework, just because that's a lot. Okay, so quiz over 7-1 is tomorrow. 7-2 is going to be over next week. We're still going to be in 7-2 for the rest of this week, so the homework for 7-2 isn't due until Monday. Okay. Any questions you guys have, or do you just want to have a little bit of time? If you want to have a little bit of time, I'm cool with that. You looking at 7-2 or at 7-3? Or 7-1? Excuse me. Okay. I was going to say, because 7-1 is what the quiz over tomorrow is about. And for 7-2, I would bet 63 is going to be very much like what we're going to do tomorrow and Friday, because we have a little bit more to go in 7-2. Okay, so answer key's up for 7-1, so you can check everything you're doing. It's the verifying stuff. It is almost entirely verifying. There's, I think, 2 questions at the end that were not the verifying, but that's the find a value. So check your unit circle values and find something that does not work. Check some things. If you find 3 or 4 things that work, see if it verifies. Okay, so look at 7-1. Make sure you're going through that because we have that quiz on it tomorrow. Okay?